Okay, let's have a look at some increasing slash decreasing annuities. So, annuity due starts at £200 per year, thereafter decreases by £10 per year. After the payment of £130 has been made, further payment ceases. So, express the present value x of the annuity in terms of A due 8 and increasing A due 8. So, let's just quickly look at this on a timeline, if you like. We'll start at time 0 and we're going to be getting paid £200. And at time 1, £190, time 2, £180, and so we can see the arithmetic progression is decreasing by 10. So with every payment period, we're getting £10 less. So times 6 is 140, and finally times 7, there we go, is 130. So we've worked out that there are 7 years or so. However, since it's an annuity due, there's actually 8 payment periods. So we can work out 1, 2, 3, 4, 5, 6, 7, 8. So this is applicable because n equals 8 in this case. Now, according to the books or the notes or whatever you're using, the way to work out something like x would be to just say q, not q, it starts off as p is before q, p minus q, and this is the amount that we first get paid, £200, and q is the arithmetic progression amount. So essentially all that just means is the amount that we're either increasing or decreasing by. So when we write it like this, we are assuming that it's increasing by q amount, but in actual fact it is decreasing. So that means we're going to be having 200 minus a negative 10. So this bit over here will add up to 210. And I'll just make that a due over there because the normal formula in the notes won't have 2 dots up there. And then we add on q, which is the amount that we're changing by, multiplied by some increasing annuity and due in this case, and that'll be 8. So to rewrite it, x will look like 210 A due 8 minus, because this is a negative 10, 10 increasing annuity due 8. Okay, and then that's the first bit of the problem. Just in terms of why we've got p minus q, and why don't we just start with p over here and then q over there. MJ, the student actuary, actually gives a really good explanation of how this is, to think of the payments being like Tetris field, which I really liked. And you can go check out his video. He's really good at all this. So now all we have to do is just find out the annuity due of 8 and the increasing annuity due of 8. So to find out an annuity due, we can do one of two ways. We can either just work out 1 minus v to the n on d, as we've done so many times, a due 8, so that would be an 8 over there, or we could also just work it out as 1 plus I, which would be 1.07 times a regular annuity. However you want to do it, doesn't really matter. I'm going to work it out in Excel anyway. Now, the other bit here over here is some people look at this and say, oh, well, I know how to find an increasing annuity. How do I find an increasing annuity due? Very simple. The exact same way as you would intuitively think. It's just like this bit. 1 plus the interest rate multiplied by a normal increasing annuity. And so that would actually be an 8 over there. So, and then this bit over here, some increasing annuity, payment period 8, is equal to an annuity due, which is what we work out over here, minus nv to the power of n, which is 8v to the power of 8, divided by the interest rate, which is 0.07. So I'll just make it I over there, and then we can just work out the answer to find out what x equals. So let's just have a quick look at Excel then. So in Excel, let's try and work out what an annuity due is. And so if we just put down the interest rate as 0.07, I've already said this is 1 plus the interest rate. This is the discount factor, 1 divided by 1 plus the interest rate. The discount factor, which is 1 minus V. And so that means the annuity due over here for 8 payment periods, n can be 8, is that. And so it's going to be equal to 1 minus V to the power of n divided by D. That is the annuity due, and that's fine. And now to find out the just increasing annuity is going to be equal to the annuity due, which we saw in the formula, minus n times the discount factor, nv to the power of n, and then that's just divided by I. Sorry, I'll just do that, divided by the interest rate. So that is the increasing annuity, but the increasing annuity due, that bit, is the increasing annuity multiplied by 1 plus the interest rate over here. So it's that bit over there. So if we have that A due is 6.4-ish, so I'll just write that down. We're going to have 210 times A due, which is about 6.4-ish, minus 10 times the increasing annuity due, which is 26.5-ish. But we'll work out the exact answer using Excel. So this is 210, so I'll put in brackets, 210 multiplied by the annuity due, and then minus 10 times the increasing annuity due. And so the answer is £1,076.82. So 1076.82, keeping the comma, remember the units that we're in pounds, and so that's the answer. Thank you very much.